In section 7.5, we're studying, this is really properties of logarithmic functions. And so our goal here is to be able to use the properties of logarithms to write expressions. So the properties of logarithms, there's three properties. So for positive numbers b, m, and n with b not equal to 1, the following properties hold. The product property log base b of m plus log base b of n is log base b of m times n. So when you have logarithms with the same base and you're adding, you get log base b of the product of those two m and n. Quotient property, log base b of m minus log base b of n. When you're subtracting, you divide m and n, so this would be log base b of m divided by n. And then the power property, log base b of m raised to the nth power is n times log base b of m. So that's, and these properties aren't true just for the log base b, these are for any base b. So this is also true for the natural logarithm where the base is b. So that holds for that as well. So that's for any base b. So example 1 has a whole bunch of parts. So let's look at example 1a. So they want us to rewrite using the properties of logarithms. So we have log base 5 of 6 plus log base 5 of 9. So I see addition. So when there's addition, there's multiplication. So log base 5 of 6 plus log base 5 of 9 becomes log base 5 of 6 times 9. So this would be log base 5 of 54. 6 times 9 is 54. So we could leave our answer like that. So this would be log base 5 of 54. That's an exact answer. We'll just leave it like that. Log base 3 of 4 minus log base 3 of 7. As long as your bases are the same, you can use the division property. Same thing for addition. The bases have to be the same. So log base 3 of 4 divided by 7 by the division property. We do 4 over 7. Part C is asking you to use the power property. So I have log base 7 of a squared. The power property says I'm just going to take this exponent and move it out front. So this is going to become 2. So this exponent moves out front. So this is 2 log base 7 of a. Part D, log base 5 of a squared b squared, or b to the 7th. Remember, if you have two letters written next to each other, it implies multiplication. So to undo the multiplication, we go back to the product property. So I can undo multiplication using this addition here. So to undo this multiplication inside the log base 5, this would be a squared plus log base 5 of b squared, or b to the 7th. So I can take this one step further, and I can use the power property and move the 2 out front, and then move the 7 out front. So this would become, well, let's not use the equal sign. So this would become 2 log base 5 of a plus 7 log base 5 of b. Natural logarithm of 25 over 3. This is going to become the natural logarithm of 25 minus the natural logarithm of 3. And that's based on your quotient property. So division is going to become subtraction. So ln 25 minus ln of 3. We can rewrite 25. Like, there's nothing wrong with this answer, but we could rewrite 25 using the exponent. So this would be ln of 5 squared minus ln 3. And then you could use your properties of logarithms. So this would be the power property. So this would be 2 ln 5 minus natural log of 3. So this would be the preferred answer. This is fully simplified. So I mean, I think these are pretty straightforward. I mean, you can go from addition to the multiplication, or you can go the other way around. You can go from the multiplication to the addition. Similar for the quotient property. You can be given the division or you could be given the subtraction, and you can go back and forth. You're free to go either way that they ask you to. The next example. So write each expression as a single logarithm. So you're going to need to use your properties of logarithms that we just looked at on that first page. So first I see numbers out front, so I'm going to rewrite them as exponents. So now I'm going the other way around. So now I'm going log base 4 of m to the power of 4 plus log base 4 of n to the power of 3 minus log base 4 of p. So that's one step. Now I see addition and I see some subtraction. So let's just go right in order from left to right here. Let's rewrite the addition using multiplication since our bases are the same. So log base 4 of m to the 4th times n cubed minus log base 4 of p. I'm going to do the next step up here. So I'll rewrite it. So this is log base 4 of m to the 4th n cubed minus log base 4 of p. So I'm almost done, and now I see how I have the subtraction. So to get rid of the subtraction, it's going to become division. That's a property of exponents. As if I'm subtracting and I have the same base, then I can rewrite it using division. So this is log base 4 of m to the 4th n cubed over log base 4 of p. And this is by the quotient property. Part B, 3ln2 minus 2ln5. So we'll use our power property to bring this 3 back to where it belongs, and then this 2 back where it belongs. So this would be ln 2 to the power of 3 minus ln 5 to the power of 2. We can take, since we have subtraction, ln 2 cubed minus ln 5 squared. So if we have subtraction, we're allowed to rewrite it using division. So we could take this as ln of 2 cubed over ln over 5 cubed. And we could simplify this. This is the natural log of, and I guess we should put this in parentheses. 2 cubed is 8, and 5. That should be 5 squared. 5 squared is 25. So it would be ln of 8 over 25. So ln 2 cubed over 5 cubed, or sorry, over 5 squared. So this would be your result. Next part. Change of base. So for positive numbers b, m, and n with b not equal to 1 and a not equal to 1, the following is true. Log base b of m is equal to log base a of m divided by log base a of b. So for change of base formula, it's probably going to be easiest to use the common logarithm. So your a would be 10, or another base that is convenient. I think for us, log base 10 is going to work just fine. But there may be cases where you don't want to use that. So let's look. Log base 2 of 3. So if we're going to use the base 10, or the common logarithm, remember log base 10 of some number x, we'll say, is the same thing as log of x. Those are the same, those mean the same exact thing. They can be used interchangeably. So in number 3a, log base 2 of 3, I can rewrite that. If I want to use the common logarithm, this would be log, so I'm using a base 10 here. And then it says I'm going to do m, so m is 3, and b is 2. So log m divided by log b. And that's as simple as those are. And then you plug them into your calculator, and this one you get about 1.58. Do the same thing for part B. Identify your m and your b. So in this case, m is 5 and b is 7. We're going to use the common logarithm again. So log of 5 divided by the log of 7. And that's, if you plug that into your calculator, you get approximately 0.83. So it's pretty straightforward doing that. I think using the common logarithm is going to be easiest. So if you stick to that, you should be just fine. Example 4, solve 2 to the power of x equals 7. So to get rid of this 2 to the power of x, again, here's some more solving. You take the log with base 2 to the x. So log base 2 of 2 to the x equals, if I use log base 2 on this side, I got to take a log base 2 on the other side. So it'll be log base 2 of 7. The 2 and the 2 to the x, or the 2 and the 2 bases cancel. So log base 2 and the base that your exponent has cancel out. So this becomes x equals log base 2 of 7. However, we have this change of base formula that says we can rewrite log base 2 of 7 as, this would be x equals, identify your m and your b. M is 7, b is 2. So this would be the common log of 7 divided by the common log of 2. And if you plug that in your calculator, you get x is approximately 2.807. So that's it for the properties of logarithms. That would wrap up section 7.5 here. If you have questions, please write them down on a sheet of paper so that you remember them, and then bring them with you to class.